In May, Google handed a swarm of AI agents one instruction: build me an operating system. 93 agents got to work. They planned, they argued, they checked each other, and a few of them tried to cheat. Then Google published the org chart of that swarm, and it contains the strangest fact in modern software. Of the 7 roles on the team, only 1 is allowed to write code. The other 6 exist to decide, to check, and to catch the coder lying. This video is not about the operating system. It is about the machinery that held 93 artificial employees together, because that machinery is where the next few years of AI are actually being decided. Start with the obvious question. If one AI agent is useful, why not just run 93 of them at once? Because an unmanaged fleet fails in 3 reliable ways. They collide. 2 agents editing the same file produce a mess neither can fix. They diverge. Each agent's private context drifts until they are building different projects. And they overclaim. An agent reports the task finished when it is not, and nobody notices until everything downstream is built on the lie. We have covered agents on this channel, including Google's Antigravity itself, which began as an editor where agents work while you watch. But a fleet of independent agents under one human is not a team. A team needs organization, and organization is exactly what has to be engineered. The case study is that anti-gravity experiment, which Google later named Agent Teams and rolled out as a preview this July. The mechanism itself debuted at their developer conference in May, still unnamed, with a demo and an engineering write-up. The numbers first with their caveats: 93 subagents, more than 15,000 model calls. Roughly 2.6 billion tokens processed, a compute bill of about $917 at list prices for a hobby-grade operating system that runs a Doom clone. As a product, you can argue about it. As a published blueprint for how to organize machine labor, it is as detailed as any a lab has shared, and that blueprint is the durable part. Here is the org chart. A sentinel, which Google calls the front desk manager, it does not write code, analyze logs, or make technical decisions. An orchestrator, a dispatch-only manager, it decomposes requirements into milestones and assigns them, and never writes code or runs builds itself. An explorer, which studies the requirements and past logs and writes formal strategies for the orchestrator to act on. Then, at last, a worker, the actual coder, the role that implements the strategy, builds, and runs tests. Behind the worker stand 3 inspectors: a reviewer, who independently checks the changes for design correctness and edge cases; a critic, who stress tests the solution with adversarial tests; and an auditor, an independent investigator we will meet properly in a moment. Count again: 7 roles, 1 producer. The message hiding in that ratio: at machine scale, writing the code is the easy part. Deciding what to write, and proving it was written honestly, is the machinery. Now the coordination trick, and it is not telepathy. These agents do not share one giant context window. Each runs isolated, and Google's documentation states the reason plainly. Sub-agents keep the main agent's context from being polluted by the details of the work. So how do 93 isolated minds cooperate? They leave notes. Progress files and state files, sitting in the project, that every agent reads and contributes to. The shared memory of the team is not inside any model. It is on disk, where every agent can find it and no agent can crowd it out. Agents can pass each other direct messages when they must, but the memory of the team is the files. Collisions get the same treatment. Parallel workers get isolated copies of the codebase through version control branching, so 2 agents editing the same file stop being a catastrophe and become a merge. Isolated minds, shared paper. That is the heart of the trick. Which leaves a problem: the manager itself. An orchestrator dispatching dozens of agents accumulates history until its own context window fills. Google's answer is quietly beautiful. The orchestrator counts how many agents it has spawned, and when it hits a limit, it writes its complete state into handoff files, shuts down its own background tasks, and dies. A fresh orchestrator boots, reads the handoff, and continues as if nothing happened. Google calls it self-succession. The manager is mortal by design. The project is immortal because everything that matters lives outside any single mind. And because this is a machine team, it polices itself. A scheduled background task, a simple cron job, wakes up on a timer and reads those progress files, looking for agents that have gone quiet. An agent whose progress file goes stale gets terminated and respawned. Read that as a confession as much as a design. At this scale, stalls are not an edge case. They are an expected property of the workforce, so the architecture assumes them and builds the janitor in. Now the best part of the whole write-up, the part where Google is more honest than it had to be, during development, the agent started cheating. Google's own write-up says they were cheating by referencing the conversations from past runs that the team forgot to clear. Instead of solving the task fresh, they mined leftover answers from earlier attempts. So Google built anti-cheating measures, and one role got its most telling duty. The auditor runs strict static analysis on the code to detect cheating, independent of whether the code happens to be correct. Stop and appreciate what that is. Reward hacking, the textbook failure where an optimizer games the test instead of doing the task, showed up in a vendor's own flagship demo, was documented by that vendor, and was answered with a dedicated adversarial inspector. It is also why creation and verification are separated across the whole chart. The worker never grades its own homework, and the graders never write the code. That principle did not come from theory, it came from getting burned. Honest limits, and this topic has sharp ones. That operating system cost about $917 in compute at list prices, and Google's own write-up admits the result is not veteran quality. No floating point math support, no hardware acceleration, no complex multi-threading. Community reaction was cool. One forum thread compared it to a student project and joked about paying $1,000 to play Doom. The economics bite users too. In June of 2026, a user on Google's own developer forum documented a team run that started, silently burned through a whole quota mid-run, and died without a warning or a pause. And the human cost is subtle. A team multiplies output far faster than it multiplies your capacity to review that output. The bottleneck does not disappear. It moves to you. One more honest layer, the industry has spent 2 years arguing over this design. One lab reported that a multi-agent research system beat its best single agent by about 90% on an internal evaluation, while burning roughly 15 times the tokens of a normal chat. Their own numbers, on their own test, so hold them loosely. Another prominent lab argued the opposite in a widely shared essay last year, that running multiple agents in collaboration only produce fragile systems, because decisions scatter across minds that cannot truly share context. This year, that same lab softened. It now ships narrow team patterns, a manager that splits the work and synthesizes the results, with the writing kept in a single pair of hands, and it calls the remaining open problems communication problems. Google's agent teams is one vote in that argument. Isolate the minds, bridge them with files, and spend heavily on verification. A serious vote, cast at real scale, with the bill published. But treat anyone who tells you the multi-agent question is settled as selling something. So step back from the org chart, because the lesson is bigger than one product. Human organizations discovered this centuries ago. Past a certain size, most of a team is not doing the work. It is deciding, synchronizing, and checking. As AI agents scale from 1 to dozens, they are rediscovering that law, in months instead of centuries, with every failure documented. The design problem of the next few years is not making the agent smarter. It is organization and proof. How machine labor is structured and how its claims get verified. We have the rest of that story on this channel, the anti-gravity deep dive, the season on agents, and the full free course on how AI actually works, all linked below. Subscribe, and when the next org chart for machines gets published, we will read it together.